Hi everyone, so today we are learning about complex numbers and solving with the quadratic formula when using imaginary numbers. So we're basing it off of last week's lesson when we used I, which was an imaginary number, when we have a negative square root. So now what we're going to do is there's going to be a possibility that when we solve with the quadratic formula, there is going to be a negative number under the square root. So now that we know that I correlates with a negative radical or a negative square root, we're just going to now use I in the quadratic formula, okay? But the first thing we're going to go over is just quick complex number. So a complex number is any number of the form A plus or minus BI, where A and B are real numbers, and I is the imaginary number. So if we look here, I'm going to highlight it. This is an imaginary number. I'm going to zoom in quick. Okay? So we're talking here about a complex number. I'm sorry, not an imaginary number. A complex number where we have one part that's real. So when we just have a number all by itself, so in this case, the 4 is real. And the imaginary part is wherever we have the I. So if an I is connected to any number, any radical, anything, ever, it's always going to be imaginary part, because there's an I connected to it, okay? So we have two different parts here. So here it just says imaginary numbers are a subset of complex numbers, and we can always write imaginary number as a complex number. So as I said before, this is a complex number, so this is important to focus on, okay? So this is a complex number, where one part is real and one part is imaginary, okay? So now we are going to focus on a few examples with just using complex numbers. So the good part about using a complex number is one part is never going to change. So in this first example, example A, we have the real part. So the real part of this problem is 16. And 16 is never going to change. So I'm just going to keep writing 16. So 16 plus. Now, here is where my imaginary number comes into play, okay? Because now I have a square root of negative 4. And we learned how to solve these last lesson. So, remember, I could break this down into negative 1 times 4, okay? And the second I see this negative 1 under the square root, I know that I could pull an I out. So now I have plus I times the square root of 4, okay? So once again, this 16 just comes down. Nothing is being changed, okay? Now, we have the square root of a positive number. And we know, this is very simple. When we have the square root of a positive number, we can just solve. So the square root of 4 is 2. And we have to remember that the I always comes second, okay? So this would be my end answer. 16 plus 2I, where this is real and this is imaginary, okay? And this whole thing would be called a complex number, okay? So that's what we're going to focus on today. We're really going to stay looking, for the next couple weeks, we're really going to focus on I, okay? So I'm going to go ahead and go over to B. So same thing with B. When we're looking at B, we're doing the same thing that we did with 16. So now we're just going to do it with 14. The 14 is always going to stay the same, okay? Negative. And now I'm just going to break down this radical so I can get a positive number under there, okay? Remember, when I have a negative 1 under the radical, that drops out as I, okay? 14 and the negative sign are coming down. And I'm still left with the square root of 32. Now, the square root of 32 is not a perfect square. 32 is not a perfect square, so I just can't take a number. So what I need to do is I need to go ahead and simplify. So I have 14 minus I, and now I need to find two numbers that multiply to give me 32, with one of those numbers being a perfect square. And I know that 16 is a perfect square, and 16 times 2 is equal to 32, okay? So I'm just going to go ahead and break it down a step further. I'm keeping the 14 minus the I the same, and I'm going to break it down the square root of 16 times the square root of 2. And I could take the square root of 16, right? So now I have 14 minus, here I'm skipping a step and I'm making sure that I put my 4 before my I, okay? Because the square root of 16 is 4, and that's going to be multiplied by the I that's outside, okay? And I cannot simplify the square root of 2, so my answer is 14 minus 4i square root of 2, where this is real and this is imaginary. Okay, the whole thing itself is a complex number. All right, so we are then going to move on to this last one. So here is just what we learned last week. This isn't a complex number, or last class. This isn't a complex number. This is just solving with a negative under the radical. So I have breaking it down to -1 times 65. I see that I have the square root of -1, so this drops out as I. And now I have the square root of 675. Okay, then I need to go ahead and find two numbers that multiply to give me 675, with one of them being a perfect square. Okay, and I know that 225 times 3 multiplies to give me 675, and 225 is a perfect square. Okay, so now I'm just going to take the extra step to break it down. Okay. And I know that the square root of 225 is 15. So 15i times the square root of 3 is my answer. 3 cannot be simplified. The square root of 3 cannot be simplified. Okay? So it just stays the square root of 3. So that is just touching base on complex numbers. Okay? It's a leading factor into using complex numbers or imaginary numbers when we talk about the quadratic formula, okay? And that's what we are going to do now. We are going to do some big examples on using the quadratic formula with I, okay? So before I do anything, I'm going to come down here and I'm going to write the quadratic formula down so you have it written, okay? Remember, we want to remember this by heart. This is super important, okay? So this is the quadratic formula. I've put it at the bottom. All right? And now what we're going to do is we're going to make sure that these are set equal to 0, and we're going to solve with the quadratic formula like we normally would. Okay? And then I will show you where the difference comes in. So I know that number 1, I'm looking at number 1, is set equal to 0. Okay? I could see that it's set equal to 0. So once it's set equal to 0, I can go ahead and label A, B, and C. And in this case, A is 1, B is -10, and C is 34. Okay? And then all I'm doing is using the quadratic formula. Okay? So nothing is new right now. So I'm going to go ahead and plug in. X equals -10. Super important that you're using parentheses every time we plug something in. Okay? Plus or minus the square root of -10 -10 squared minus 4 times A, which is 1, times 34, which is C, all over 2 times A. Okay? So I really tried to express that we need to put parentheses around everything that we plug in. Okay? And now we're just going to go ahead and simplify the first couple parts. So I know that when I have a negative and a negative, this becomes a positive. So I am left with x equals 10 plus or minus, and now we're just going to do some simplifying under the radical. So we're just multiplying, okay? And I know that -10 squared is 100, okay? And then I'm going to focus here. I need to do some multiplication with these three numbers. So -4 times 1 is -4, and -4 times 34 is -136, all over 2 times 1, which is just 2. Okay? And then we're just going to keep going. So now we need to work on simplifying the radical. So what I'm left with is x equals 10 plus or minus the square root. And here we are focusing now on 10 minus 136. 100 minus 136. And 100 minus 136 is negative 36. All over 2. Okay? And now this is where our quadratic formula changes a little bit from what we learned last time. Okay? So now we have a negative 36 under the radical. Okay? And I know that, I'm going to keep this, that when I have a negative number, I could say negative 1 times 36, because the whole point of today's lesson is getting that negative out of the radical and using an imaginary number. Okay? So now that I'm looking at this, I see that I have a negative 1 under the radical. And I know that the square root of negative 1 equals I. Okay? So now what I can do is I could pull this I out. So I have 10, or x equals 10 plus or minus I, times the square root of 36 all over 2. Okay? And then my last step is simply just to, sorry, I have to erase this whiteboard more. Simply just to take the square root of 36. And I know that the square root of 36 is 6. But I cannot forget to keep my eye with it. Okay? And here, now I have my answer. Okay? Because we have an imaginary number, we cannot really simplify this much further. Okay? There is a way, but actually, we're going to work on simplifying. So, we need to go ahead and then simplify this. So when we are looking for to simplify, we need to know that this 2 goes over both numbers. Okay? So here, like I was saying, we have to make sure that we are putting the 2 to both terms. Now, what's important is we can't forget that this was a plus or minus, okay? So what I'm going to do is I'm going to break it up into 2 different equations, okay? And what I mean by that is I'm going to have x equals 10 over 2 plus 6i over 2, and I have x equals 10 over 2 minus 6i. Ooh, I want to do that in a different color. Minus 6i over 2. And now we just can go ahead and simplify it. So what we're going to do is we're just going to divide each of the numbers by 2. So I know that 10 over 2 is 5, and I know that 6 divided by 2 is 3, but I cannot forget to keep my eye. Okay? So here we are with a complex number and an answer. Where this is going to be, the second one's going to be the same thing, but I just have a minus sign now. Okay? So this is important. So this is how we would complete something like this. Okay? All right, so we're going to go ahead and please take a picture of that. I have to erase it because it won't stay set. Okay? I don't know why that's happening. So please take a picture. I'm going to erase now. All right, so we're going to do another example. Okay, so now we are on number 2. All right? So I'm not going to forget that my quadratic formula is over here. Okay? And the first thing I'm going to do is I need to get this in standard form. This is not set equal to 0. So I need to subtract this 2 from both sides to get a 0 on the right. So now I have 9x squared plus 10x minus 5 equals 0. And now I'm set equal to 0, so what I can do is go ahead and label. So my A is 9, my B is, oh, this is a positive 5, my bad. My B is 10, and my C is 5. Okay? And then what I'm going to do is just plug into my quadratic formula, which is in the bottom of the right screen. So I have x equals -10 plus or minus the square root of 10 squared minus 4 times 9 times 5 all over 2 times 9. Okay? So I just plugged in my a, b, and c. So now I'm just going to go ahead and simplify. So x equals -10 plus or minus the square root of 10 squared, which is 100, and then -4 times 9 times 5 is a -180. And I can't forget to keep this all over 18. Okay? So now we're going to focus on simplifying this radical. So now I have x equals -10 plus or minus the square root of 100 minus 180, which gives me a -80 all over 18. Okay? And then we are going to, then we need to focus on this. So here is where my I comes into play, because I have a -80 and a -80 under the square root. So same thing, x equals -10 plus or minus the square root of -1 times 80. Now we do that so I can get this -1, this negative, out of the radical. And I know that the square root of -1 equals I. So now that I know that, what I can do is, because I have a -1 under the radical, I could pull an I out and keep the 80, the positive 80, under the radical. Okay? Now, I know that that 80 is not a square root. It's not a perfect square. I mean, I can't take the square root of 80 and get a number out. It's going to be a large decimal. Okay? So what I need to do is I need to find two numbers that multiply to each other to get me 80, with one being a perfect square. And I know that 80 is divisible by 16 and 5, so I'm going to use those two numbers because 16 is a perfect square. Okay? So my next step is then to simply just go ahead and take the square root. I know that I could take the square root of 16, right? And the square root of 16 is 4. And I keep the square root of 5 under there because that cannot be simplified any further. Okay? So I just skipped a step knowing that the square root of 16 was 4. And I connected it with the I. Okay? Now, you can leave your answer as so. Okay? This one's a little bit more difficult to simplify, so we're just going to leave that there. All right? Making sure that we know that this plus or minus tells us that there's two answers. Okay? That's important to remember. All right, now we're going to do number 3. Okay? So this one is already set equal to 0, so I don't need to worry about that. So I'm just going to go straight into labeling A is 1, B is -14, and C is +50. Okay, and then I'm going to use my quadratic formula. So I'm going to write this as negative times -14 plus or minus -14 squared minus 4 times 1 times 50, all over 2 times A, but A is 1, so I'm just going to put 2. Okay? And now I'm going to go ahead and do some multiplication and simplify. So x equals a negative times a negative gives me a +14, plus or minus 14 squared, which is 196. And then I need to go ahead and multiply all of this. So -4 times 1 times 50 gives me a -200 all over 2. Okay? And then one more simplification step is just to do the math under the radical. And 196 minus 200 is a -4. Okay? So here I notice I have a negative under the radical. okay? So what I'm going to do is break this up into -1 times 4 under my radical, okay? And then I am able to notice that, reminder, square root of -1 is equal to I. So I'm able to notice that I have a -1 under my square root. So when I have a -1 under the square root, what I can do is pull out an I. And I'm still now I'm just left with the square root of +4, okay? And I know that the square root of +4, because 4 is a perfect square, is just 2. So x equals 14 plus or minus the square root of, or plus or minus 2i all over 2. Okay? And now because there's no radical left, I'm going to go ahead and simplify this. So, reminder, we need to break this up into 2 different problems. Okay? So I'm going to actually do it this way. So, I have x equals 14 all over 2 plus 2i over 2, and x equals 14 over 2 minus 2i over 2. And we can just simplify this. So we're going to divide the 14 by 2, which gives me 7, plus, and 2i divided by 2 is just I. So this is one answer. Okay? And then my other answer is going to be the same thing, but just with a negative sign. Okay? And this is my second answer. All right? So, what you guys are going to do today, okay, you're going to do this next. There's 2 pages. Okay? There's 2 pages of practice problems. Now, I am going to tell you, actually I'm not. I want you guys to try and focus. I'm going to tell you that 7 of the problems will include I. So 7 of them, you're going to have a negative square root. And the other 5 of them is just normal quad formula with no I. Okay, I'm not going to tell you which ones are which, but there's going to be 7 of them that are going to include I and 5 that do not. Okay? Now, this is important to make sure that we are moving. If this is not set equal to 0, we need to be moving things, okay? I cannot start using the quadratic formula if I am not set to standard form, which is ax squared plus bx plus c equals 0, okay? So if you need to be writing these things down, I'm going to also write down the quadratic formula so you have it. Okay, so these things are important to remember. And don't forget that the square root of -1 equals I. Okay, so these are 3 important things that you need. So if you would like to write them down, go ahead and do so. Okay. If you have any questions, come, either on Zoom later today or email me, please, okay? I know this could be a bit of a confusing lesson. All right, have a good day.